Hi, this lesson is about the derivatives of trigonometric functions. So there are 6 trigonometric functions and their derivatives are here in this table. So the derivative of sine of x is equal to cosine of x. The derivative of cosine of x is equal to negative sine of x. The derivative of tangent of x is equal to secant squared of x. The derivative of cosecant of x is equal to negative cosecant of x cotangent of x. The derivative of secant of x is equal to secant of x times tangent of x. And the derivative of cotangent of x is negative cosecant squared of x. So let's use these new derivatives as well as in combination with other rules that we already learned, like product rule, quotient rule, chain rule, and power rule. So this first problem asks us to find the second derivative of y equal to sine of x. Well, the derivative of sine is cosine. That's exactly the first one that I gave you. Then the second derivative is the derivative of the first one. So the derivative of cosine is negative sine. That's exactly what the second rule that I gave you above. So if we were to continue, if I asked for the third derivative, it would be the derivative of negative sine. So that would be negative cosine of x. And if I asked for the fourth derivative, then that would be the derivative of negative cosine. So that would be negative sine of x, which would give you sine of x. And you can continue with the fifth, sixth, seventh derivative, and it basically would start a pattern because like the fourth derivative is the same as the original. So the fifth derivative would be like the first derivative. Okay, so for number 2, we have y equals x squared cosine of x, and we're asked to find the derivative. So here we have to use our product rule because we have a product of two expressions. So our setup is right here. If f is the first function, x squared, then f prime is 2x, and g is the second function, cosine of x, so g prime is negative sine of x. So when I plug that into the product rule formula, right here I get f g prime plus f prime g, and all I did from this line to the next line is I put this minus in front, the negative. That first expression is negative, so your answer is negative x squared sine of x plus 2x cosine of x. All right, so now we're going to prove that the derivative of tangent of theta is secant squared of theta. So I gave that to you here, but we're actually going to show how to derive that by using our quotient rule. And the reason why we can use quotient rule is because tangent of theta is equivalent to sine of theta over cosine of theta. So that's something we learned in pre-calculus. And so if your f is your numerator sine and g is your denominator cosine, then f prime is cosine of theta and g prime is negative sine of theta. So when we put that together in our quotient rule, remember it's g f prime, you have to multiply these two first, minus f g prime, which is exactly what we see right here, over g squared. Remember this notation, cosine of theta squared means the same as writing it like this. So it means that the cosine function is being squared. So it's typical to put that square in between the function and the angle, but the order of how it's evaluated is cosine of theta is evaluated, then you square it. And in the numerator, when you multiply these two together and these two together, gives you cosine squared of theta plus sine squared of theta. And hopefully you remember that that numerator is one of the Pythagorean identities, and this is equal to 1 by definition. And so 1 over cosine squared is equal to secant squared of theta, because cosine and secant are reciprocals of each other. So you should remember that cosine of theta equals 1 over secant, but also the opposite is true. Secant of theta is 1 over cosine. So we have this scenario, except the cosine is squared. All right, so for the next problem, we are asked to find the slope of the tangent line to the curve of f of w equal to 4 cotangent of w, and we're going to evaluate it at 3 pi over 4. So this is very straightforward. It's just the coefficient of 4 times the cotangent of w, so I just have to multiply 4 by the derivative of cotangent. And the derivative of cotangent is negative cosecant squared. If we look back here, it's negative cosecant squared. So my derivative for this problem is negative 4 cosecant squared of w. So now I'm going to plug in the 3 pi over 4. And remember that squared means that I'm actually going to evaluate cosecant of 3 pi over 4 and then square that result. Now, 3 pi over 4 is is in quadrant 2, and it is a special angle. It's a 45-degree reference angle in quadrant 2. And so we should remember that 45 degrees has the opposite side of root 2, the adjacent side is negative root 2, and the hypotenuse is 2. And cosecant is the reciprocal of sine. And so if you remember, SOHCAHTOA, sine is opposite over hypotenuse. So we want hypotenuse over opposite. And if you were to rationalize that by multiplying by root 2 over 2, you get 2 root 2 over 2. But these cancel, so your answer is just root 2. So that's exactly what you see right here. But then we have to square that, and root 2 squared is 2, and multiply that by negative 4, and so we get that the slope of the tangent line is negative 8. Okay, so we move on to the next one, which asks us to find the equation of a tangent line at x equal to pi over 3 for y equal to negative cosecant of x. All right, so to find the equation of a line, we need a point and a slope. So we have part of the point, we have the x value, so you find the y value by just plugging in pi over 3 into the original function. So negative cosecant of pi over 3 is a 60-degree angle. And so again, this is another triangle that we should know. Opposite of 60 is root 3, opposite of 30 is 1, and then we have our hypotenuse of 2. And cosecant, as I mentioned in the last problem, is the reciprocal of sine. So that's going to be hypotenuse over the opposite side. So that's why I get 2 over root 3, but there's a negative in front of the function. So it's negative 2 over root 3. And if you rationalize it by multiplying both sides by root 3 and root 3, or numerator and denominator, you'll get that your y value, or the second coordinate of the point, is negative 2 root 3 over 3. Okay, but now we have to find our derivative, because our derivative is the slope. The derivative of just cosecant is negative cosecant of x cotangent, but there's a negative in front, so this negative goes in front here, so the double negative makes the expression positive. Then I just have to plug in pi over 3. So again, that triangle, I drew it here below. It's a 30, 60, 90. When I plug in pi over 3, I have to evaluate the cosecant of pi over 3 and cotangent of pi over 3. So we know that cosecant is 2 over root 3, just like we found earlier. And cotangent, well, that's the reciprocal of tangent, and we know that tangent is TOA, opposite over adjacent. So it's adjacent over opposite, so it's 1 over root 3. So when I multiply 2 over root 3 times 1 over root 3, you get that your derivative, which is the slope, is equal to 2/3. So now we apply that slope and the point to our point slope formula, which is right here. So it's y minus my y coordinate is equal to my slope, m, times x minus my x coordinate, which came from the original problem. And then the rest of it is just isolating y on the left side. So the left becomes y plus 2 root 3 over 3. And on the right side, you distribute the 2/3, so you get 2/3 x minus 2 pi over 9. And then subtract this over here. And so you get a final answer of y equal to 2/3 x minus 2 pi over 9 minus 2 root 3 over 3 as the equation of the tangent line. Okay, so for this next example, we want to find the derivative dy dt for y equal to secant of t divided by 3t plus tangent of t. So here we have to use quotient rule. And so my numerator is f and my denominator is g. And so here my f prime is secant of t tangent of t. That was one of the new derivatives that we learned that's in the table above. And the derivative of g is 3 plus, and here's again a new derivative. The derivative of tangent is secant squared of t. So we just have to plug that into your quotient rule. So remember, it's g f prime, so these two get multiplied together, minus f g prime, so those two get multiplied together, over g squared, so this expression gets squared. And then the rest of it is a little bit of just simplifying. So I can see that in my numerator, I have a common factor of secant. And so I factored that out. So that came right here to the very beginning. And then I wrote down what was left and also distributed. So when I factored out that secant, I still had a tangent. So when I distribute the tangent across, you get this expression. You get 3t tangent of t plus tangent squared. And when I factored out that secant, well, this one went to the front, and I was just left with 3 plus secant squared, but this minus got distributed. So I end up with minus 3 minus secant squared of t over my common denominator, the g squared. So it's a good idea to always look for something in common and factor it out, because sometimes you can simplify your expression. In this case, you can't. So both this line and this line are equivalent. Okay, so here's another problem where we're going to prove that the derivative is what it is. So here I want to prove that the derivative of cotangent of theta is negative cosecant squared. Similar to the one I did earlier regarding tangent, I'm going to rewrite cotangent as cosine over sine, which means I'm again using quotient rule. But this time my f is cosine, the numerator, and g is sine, the denominator. So f prime is negative sine of theta, and g prime is cosine of theta. Then we plug it into our quotient rule. So right here you see g f prime minus f g prime over g squared. The numerator, when you multiply, becomes negative sine squared of theta minus cosine squared of theta over sine squared of theta. And then in the numerator, you can factor out a negative 1. So I get negative 1, and then in parentheses, sine squared of theta plus cosine squared of theta over the same denominator. But again, this is right here, that's the Pythagorean identity. That is equal to 1. So my numerator is negative 1 over sine squared, but sine and cosecant are reciprocals of each other. So sine of theta is 1 over cosecant of theta, but also cosecant of theta is 1 over sine of theta. So we have this scenario in this problem. So negative 1 over sine squared is equal to negative cosecant squared of theta. And so that is the derivative. And that's it for this lesson. So give the homework a try. Good luck.